We're going to continue our study of logic and reason with this lesson on conditional statements. The objective is to recognize conditional statements and their parts and to write converses, inverses, and contrapositives of conditionals. So what is a conditional? A conditional is an if-then statement. I could say, if it is cloudy outside, then it will rain. And that would be a conditional statement because it's written in if-then format. Sometimes we use symbols P with an arrow and a Q to represent a conditional. And you would read that if P, then Q. Or you could also read that P implies Q. So in the statement that I just gave, if it is cloudy outside, then it will rain. The part of the statement after the if that says, if it is cloudy outside, is the hypothesis. So it's the words that follow the if, which are the P part with the P and Q symbolism. And then the part that says, then it will rain, the statement, it will rain, is the conclusion because it follows the word then, and it is the Q part of the if P, then Q. So let's look at a couple of problems that use this. So in problem 1, you are identifying the hypothesis and conclusion of a conditional statement. The statement says if a number is even, then it is divisible by 2. So the part of the statement that says a number is even, the part that follows the if, that's the hypothesis. Or if you're using the P and Q symbols, that's the P part. The part that follows the then, that says it is divisible by 2, that's the conclusion, or the Q part with the P and Q symbols. In problem 2, you're asked to write a conditional and make the statement that's given into a conditional statement. The statement that's given says adjacent angles share a side. So you just need to write that in if-then form to write it as a conditional. It's helpful to remember from English how to identify the subject and the predicate of the sentence to do this. So the subject of this sentence would be adjacent angles, and the predicate would be share a side. So let's take the subject and make that into the hypothesis that follows the if, and then we'll take the predicate and make that into the conclusion that follows the then. So let's rewrite this saying if two angles are adjacent, then they share a side. Now notice that sometimes you might have to add some words to make the sentence make sense. Sometimes you might have to change the verb tense to make the sentence make sense, but it still says the same thing as the original statement. It's just now in if-then form. Back to our vocabulary, the truth value of a conditional is either true or false. To show that a conditional is true, you have to show that every time the hypothesis is true, then the conclusion is also true. But to show that a conditional is false, you have to find only one counterexample for which the hypothesis is true and the conclusion is false. to prove that the entire conditional is false. So let's look at problem 3 as an example. In problem 3, the first statement says, if you live in Miami, then you live in Florida. Now the book answer to this question is that it's true. However, if you live in Miami, Oklahoma, you would have a good counterexample that it's not true. So I'm going to say that this one is false. And the counterexample is Miami, Oklahoma. And there are several other states that have a city named Miami as well. That could be other counterexamples. The second statement says if a number is divisible by 5, then it is odd. That one is also false. And just have to provide one counterexample where that is false. And the counterexample here, one example, is that 10 is divisible by 5. But it is not odd. Our next definition is the negation of a statement. P is the opposite of a statement, of that statement. So you would write that. The symbolism for that is a squiggly line and a P, and you would read that not P. Let me write that a little better. Not P. The converse of a conditional statement exchanges the hypothesis and conclusion. Another type of statement we're going to look at is an inverse of a conditional statement, and it negates both the hypothesis and the conclusion. And the third type of statement we're going to look at is a contrapositive. Contrapositive of a conditional statement both exchanges and negates the hypothesis and the conclusion. Or you can say that it negates the converse, since the converse already exchanges it. So let's look at problem 4. In problem 4, it's writing and finding truth values of statements. So we're going to take a conditional statement and write its converse, inverse, and contrapositive. You might want to do this on the back of your paper, since it takes a little more room to write each one of these. The original statement is if a figure is a rectangle, then it is a parallelogram. So that's our original conditional if-then statement, and that is a true statement. If you'll remember when we did the quadrilateral task in class earlier this year, and I gave you a quadrilateral family tree to indicate which quadrilaterals were parallelograms. The parallelogram was toward the top of the family tree, and the rectangle was below it, indicating that it is a parallelogram. So let's write the converse of this statement. The converse of this statement, we would exchange the hypothesis and the conclusion. So in our original statement, if a figure is a rectangle, then it is a parallelogram. The hypothesis is a figure is a rectangle. And the conclusion is it's a parallelogram. So we're just going to switch those for the converse. And we're going to say if a figure is a parallelogram, and I'm going to use the symbol for a parallelogram just to shorten it a little bit. If a figure is a parallelogram, then it is a rectangle. Now that statement, is it true or false? That statement is false. And to show that it's false, you provide a counterexample. The counterexample is that it could be a rhombus, and it would still be a parallelogram, but it wouldn't be a rectangle. So it could be a rhombus. So that was false. Where the original conditional was true. So now let's look at the inverse. To write the inverse, takes the original conditional statement and negates both the hypothesis and the conclusion. It keeps the same order, it just negates each one of them. So the inverse of this statement would say if a figure is not a rectangle, then it is not a parallelogram. Now that statement, once again, this one is false. And counterexample, going back again to the rhombus, a rhombus is a parallelogram. That is not a rectangle. The last type of statement we're going to write is the contrapositive. So the contrapositive, looking back at the definition, it both exchanges and negates the hypothesis and the conclusion. So to make this statement, you would say if a figure is not a parallelogram, so we're switching it and negating it. If a figure is not a parallelogram, then it is not a rectangle. So if it's not a parallelogram, it's not a rectangle. That is a true statement. Because in order to be a rectangle, it has to be a parallelogram. So let's go back over and finish our definitions on the left side. The last of our definitions is equivalent statements. Equivalent statements have the same truth value. So if we look back at the example that we just did in problem 4, the conditional and its contrapositive are always going to be equivalent statements, and in our example the conditional and the contrapositive were both true, and the converse and the inverse are also going to be paired together to be equivalent statements. And in problem 4, the converse and the inverse were both false, so that made them equivalent statements because they were both false.